Okay, now what we're going to do is we're going to look at a couple of other uh, polynomial functions here. And what we're asked to do first is perform polynomial division on each of the functions below. And then we're going to state the horizontal asymptote. So uh, we'll perform polynomial division. Well, polynomial division, we can do long division, or we can do synthetic division. I prefer synthetic division. So I'm going to take this first function, 7x minus 5, divided by x plus 2, and I'm going to use synthetic division. So I take the x plus 2, set it equal to 0, solve, I get x equals negative 2, and I'm going to divide now using synthetic division, the 7x and the negative 5. Drop down, negative 2 times 7 is negative 14. Add that up, I get negative 19. So that means that this must be 7, right? So we had a degree 1 initially. We drop a degree, so it's a degree 0. And then it's the remainder of negative 19 over the divisor of x plus 2. Let's look at our next function. X minus 4, set it equal to 0. And solve, we get x equals 4. We're going to divide it into the 6x plus 3. Drop the 6 down. 4 times 6 is 24. 24 plus 3, 27. We had a degree 1 to start. We dropped down a degree. So this is 6 x to the 0. So it's a constant. Plus our remainder of 27 over x minus 4. My last one, I notice that I'm dividing by a linear binomial. That's good. But I notice that my coefficient here is a 2. So instead of doing long division, instead of doing synthetic division, I'm going to choose to do long division. So 2x plus 1. And I'm going to divide that into 4x minus 9. I'm going to use long division. 4x divided by 2x is 2. Multiply. 2 times 2x is 2x. 2 times 1 is 2. Now I subtract that. Oh, 2 times 2x is actually 4x. I don't know why Mason didn't correct me. There we go. 2 times 2x is 4x. 4x minus 4x, those cancel. Negative 9 minus 2 is negative 11. So then my quotient is 2 minus 11 over 2x plus 1. And just for clarification, I'm going to write this quotient that we got. I'm going to bring it down here and write it. We got 2 minus 11 over 2x plus 1. So when I divide these three functions, these are the three quotients that I got. I got 7 minus 19 over x plus 2, 6 plus 27 over x minus 4, and 2 minus 11 over 2x plus 1. Okay? Now, we also need to find the horizontal asymptotes of each. And to do that, we're again going to go to Desmos. We'll put them into Desmos and see if we can find the horizontal asymptotes. So feel free to pause this video, jump into Desmos, type these functions in, and then we'll look at the functions one at a time. We're back here. We have our first function, 7x minus 5 divided by x plus 2, and we were asked to find the horizontal asymptote. So I graphed the function, and I can see that there is a horizontal asymptote, but it's kind of hard to see where exactly it is. So this is 10. So if I zoom in maybe a little bit here, there's 5. This is 7. So it appears that this might be 7. A good way that we can check this is if we zoom out, right? I zoomed out quite a bit. All you got to do is put your mouse on the function and then drag and look at the y values. Look at what my y values are getting really close to. As I move further and further to the left, look at the y values. 7.66, 7.6, 7.6, 7.5. It's getting closer and closer and closer, it appears, to 7. Now let's look at it from the other side. Click on this and go across. There's a y value of 6. Y value is 6.5. So it appears, this is 6.7 right in here. It appears that as my x values get farther and farther and farther to the left and farther and farther and farther to the right, it appears that my y value is getting closer and closer and closer to 7. So let's remember that our first function looks like it has a horizontal asymptote at y equals 7. Let's look at our second function. So our second function, we're going to do the same thing. We're going to click and drag. There's 7.2, 7.1. Okay, it drops below 7, and it keeps going down, going down, going down. It looks like it's getting closer and closer and closer to, this time, 6, 6.4, 6.3. So it looks like it's, as I move further and further and further to the right, my y value gets close to 6. Let's look at it on the left-hand side of the graph. So if I take my graph and I move farther and farther and farther to the left, look at my y values. They appear to be getting closer and closer and closer again to 6. So there's 5.8. Right? See how it's really slows down how much it's growing. So it looks like it's not really going to get to 6. So for this second function, it appears that my horizontal asymptote as y equals 6. Our third function, the 4x minus 9 over 2x plus 1, do the same thing, and I click and I just follow this function across, and 1.8, 1.9, looks like it's getting really close to 2. On this side, again, it's above 2, but it looks like it's getting really, really close to 2, but it's not going to actually reach 2. So I would say for this third function, it appears as though my my horizontal asymptote is y equals 2. So now we can go back to our notes and we can type in here for each of these. The first one, we said that it appeared to be y equals 7. For this second one, it appeared to be y equals 6. And for this third one, it appeared to be y equals 2. Now what I'd like you to do is I would like you to look at these constants that we ended up with when we did our polynomial division. So our horizontal asymptotes appear to be those constants. Okay, so let's think about where those constants came from. So this constant, this 7, came directly from the leading coefficient of our came from the leading coefficient of the polynomial that was in the numerator. If we look at our second one, the same thing. And the third one, same thing. This constant comes from this leading coefficient. Or does it? Well, this is a 4. But notice this 2 came from dividing 4 by 2. So 4 divided by 2 gives me that 2 for my horizontal asymptote. Can answer some of these questions. For each of these functions, what's the degree of the numerator? So for each of these, the degree in the numerator was a 1. What's the degree of the denominator? Well, for each of these functions, the degree in the denominator was also a 1. Where was the horizontal asymptote? If we really investigate it and we really look closely, it looks like our horizontal asymptote comes from taking the leading coefficient in the numerator and dividing it by the leading coefficient in the denominator. Okay, so my horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient in the denominator. Is there a pattern? Yeah, there probably is. I would say yes, there probably is. Notice that I had degrees that were in the numerator and denominator were the same, and my horizontal asymptote happened to be just divide out those leading coefficients. If that's the case, without doing any long division, let's state the horizontal asymptotes here. Well, if I want to find the horizontal asymptotes for f of x, all I have to do is divide the leading coefficient of the numerator by the leading coefficient of my denominator. 4 divided by 1, I should have a horizontal asymptote here of y equals 1. Let's look at g of x. If I take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator, I should have a horizontal asymptote of y equals 5 over 2, which is really going to be on a graph 2.5. And then last but not least, if I can get my screen to cooperate here, there we go. Look at function h of x. If I want to find my horizontal asymptote here, all I really need to do is look at the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. So my horizontal asymptote is going to be the line y equals 8 over 4, which is 2. Okay, so when my two degrees match in the numerator and the denominator, if you're looking for the horizontal asymptote, all you really need to do is divide those leading coefficients.